All right, AP, let's do this. 15.3 and 4, we're going to interpret and we're going to work with the equilibrium constants. Okay, so take a minute, read the two learning objectives. Basically, the value of K tells us something, and then we're going to actually do some calculations with KC and KP. So let's first look at the value of K. Okay, so make sure you guys have calculators too. Take a minute, read the two learning objectives, highlight and annotate as always. Okay, I like my way, and you know Rodriguez likes her way. I have a little trick of remembering about the value of K. All right, well, first of all, when K equals 1, whether it's KC or KP, whatever it is, you are at equilibrium. One side of the equation is not favored than the other. But the problem is the value of K can be actually really big or really small. So that means one side actually is favored. So let's say your K is really, 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 really large. Okay, so way greater than 1. Okay, what happens is you actually think of a teeter-totter, like a seesaw back in the day. Okay, when your value is so greater than 1, so large, okay, you actually have more products. So it's kind of like this. If this is your reactants mix products, your products are kind of weighing this reaction down, okay? So at equilibrium, you have way too much products, and the products are favored at equilibrium. So the equilibrium shifts, or not, sorry, don't say the word shifts yet, not yet. Equilibrium lies to the right. Now, why on the right side? Well, because the products are on the right side, okay? No brainiac moment there. But how do you remember when K is larger than 1 that it's favored with the products? I like to use these little greater and less than signs and create kind of like an arrow. Pretend that you're seeing like an arrow. That means the arrow is pointing to the product side, pointing to the right side. So that means at equilibrium, your products are favored because you have a lot of products. So equilibrium lies to the right, okay? Think of it if K was smaller, okay? So keep it K first, and then your little greater and less than signs. So in this case, my arrow, if this is my reactants make products, okay, my arrow is pointing to the reactant side. So that means my reactants, beyond reactants, okay, I have beyond way too much reactants at equilibrium. So that means the reactants are favored at equilibrium, and that means it lies to the left. And why to the left? Because the reactants are on the left side of the arrow, okay? Don't beat it to death. It's just a cute little trick that I have. But in order for you to do this trick, you have to write the K first and then the 1. Like if you write the 1 and then the K and try to do this, it doesn't work out that way, okay? So write the K first and then the 1, okay? Let's do a little example, okay? Let's say you have this equation. We've already seen this equation. This gas produces 2 moles of this gas. So when we write our KC or KP, products over the reactants, okay? And remember the coefficients, because they're elementary reactions, they're the orders, okay? So when I write my KC expression, one other reminder, only gases and aqueous. So I have 2 gases. So my NO2 squared, because the coefficient, over the reactant, N2O4. I say that my K is 0.212, okay? So here's my first question. Does the reaction favor the reactants or products? Okay, well first tell AP, since my K, now this number is less than 1. So because my number is less than 1, I always get the question, do I have to put, in your notes, you put the 2 greater and less than signs. Do I have to put the 2? No, you can just put 1. I just always put more than 1 because maybe it's beyond small so small or so large compared to the number 1, okay? So since my k is my k is less than 1, so we're going to pretend that we see our arrow, okay? But don't do that in your essay on the AP test, okay? So because my k is less than 1, that means my equilibrium is favoring the reactants. So my reactants are favored at, you can do the at sign, at equilibrium. Okay? So because my reactants are favored, does my equilibrium lie to the left or to the right? Well, the reactants are on the left side, so it goes to the left side. Okay? What happens if the equation is flipped? So if you reverse the reaction, what happens is the equation gets flipped, but the K becomes the reciprocal, okay, of that original reaction. So when the reaction gets flipped, you have to take the reciprocal, which is also another way of saying the inverse, okay, 1 over the original of that Kc value, okay? So if my Kc, write the expression, so now I'm going to have N2O4 over NO2 and then squared. Well, because my reaction was flipped, I have to take the reciprocal and put 1 over 0.212. So let's plug this in the calculator, turn it on. So I'm going to get 1 divided by 0.212. And I'm going to get, it looks like 3 sig figs, so 4.72. Okay? So now, look at my new K. Since now my K is greater than 1. All right. So if I'm looking at my arrow, okay, that means this time, because my arrow is pointing to the right, my products are favored. What? By you flipping the equation, now the products are favored? And that means if the products are favored, that means it's lying to the right side, okay? But I want you to see something. In this equation, because we flipped it, the products that were favored, look at who the chemical is. Now go back above. We said the reactants were favored, and who's on the reactant side? The same chemical. The point is, ladies and gentlemen, just because you flip an equation or you manipulate the equation, whatever chemical was favored on one is going to still be favored on the other, okay? No matter what you did to it, okay? So pay very close attention to what you do to these equations so that way you know who is favored, okay? We are now going to look at what happens when you take more than one elementary step, kind of like chapter 14, where we put 2 elementary steps together to make a mechanism. Here's the rules, okay? So take a minute. This is Learning Objective 7.D. If you do something to the equation, what happens to the K's? Okay, so take a minute to read the learning objectives, make some notes, annotate. What does AP expect you to master? So relating the chemical equations to the equilibrium constants, if a chemical equation is modified in any way, the equilibrium constant changes too because of that modification, okay? So there's 3 common modifications that happen. So whatever you do to the equation, the K gets affected, okay? So number 1, if you flip the equation, the K is now the reciprocal. So now you have to take 1 over whatever that K value was, okay? That's if you flip it. What if you manipulate the coefficients? So maybe like you multiply the coefficients, well then you take that Kc and you raise it to that power. So maybe you took the coefficients and let's say if the coefficients were multiplied by 2. So then now we're going to call this Kc. It could do Kp also. So my Kc gets raised to that 2. Okay? But beware, what if the coefficients were maybe divided by 2? Maybe you had like some fractions. Okay, so in that case, then my Kc, you raise it to the 1/2 power. Well, for those of you in math, and if you're learning math, what is Kc to the 1/2 power? Well, we call that the square root. Okay? Whatever you do to the coefficients, you raise it to that power. Okay? So now, chapter 14. Okay? We're going to take elementary steps, and we're going to take whatever elementary steps we want, and we're going to put them together to make the mechanism. Okay? So, will you see some intermediates and catalysts? Absolutely. Okay? But the question is, what happens to these K values to get the mechanism? So step number 3. Okay? If you have 2 or more elementary steps, you add up the reactions. Okay? But since you add up the reactions, what do you do to the Ks? Well, you multiply the Ks to get the overall equilibrium. So this K value right here, overall, you're going to take your Kc1 and times it by Kc2 and so forth, okay? Remember, Ks, and I'll put them up here, Kc and Kps, they have no units, okay? So that means you can't screw up the units part, but beware of the sig figs, okay? So let's see an example. I spelled one out for you. HF breaks up into the ions, and that's its Kc value. And then this aqueous acid breaks up into these ions. There's his Kc value, okay? Determine the Kc for this mechanism. So that's the mechanism that we want. So these are your elementary steps, step 1 and 2, and then this is my mechanism, okay? I'm just going to make a note here from chapter 14. Be on the lookout for catalysts and maybe intermediates. Okay? All right, so the name of the game is this. I always like to figure out first, do I need to flip any equations? Do I need to flip anything? Because the name of the game is for mechanisms, I got to get the chemicals that I need on the right side. So right here, I have my HF, and I have them where I want. So I know I don't want to flip this first one. Now the second equation, notice this H2C2, he's over here. He's on the product side. So what I do is I tell AP, right in the margin, I flip this equation. So now, because I flip step number 1, I take the reciprocal of my K value. So 1 over 3.8 to the negative 6, well, I get this 2.6 to the 5th. Remember, this was a really small number, and when I take the reciprocal, it's now a really big number, okay? So I have the chemical where I want him, right there, okay? I have, let's see, who else do I have? I have this ion right where I want it. Okay, but the second equation has these coefficients, okay? So that means I have to multiply by 2, and when I multiply by 2, everybody gets that 2. If they already had a coefficient, you still have to multiply by 2. So because I multiply by 2, I have to raise it to that power. So 6.8 to the negative 4 squared, and then I get 4.6 to the negative 10. Now I have this, okay? I have my 2 HF where I want them, and I have my 2 F minus. So now the question is, what about this 2H plus? On the product side, he was produced and then consumed. That's called a catalyst. Sorry, I almost had a moment there. My H plus, that's an intermediate. Okay, and I don't see a catalyst in this one. So now you add up the equations, but you multiply the Kc values. So you're going to take this Kc value and you're going to multiply it by this Kc value. So what work do I need to show? Well, exactly what I just did in orange. You tell AP what you did to the first equation. You tell them what you did to the second. You show your work. And then Kc overall, and then you just write a little equation. Kc1 times Kc2, and then you get this value, okay? Now, my overall equation, my mechanism was 0.12. So which side does equilibrium favor? Well, that number is less than 1. So since K is less than 1, and I'm looking at my cool trick of my arrow, and that means it looks like it's going to be favoring my reactants, okay? So my reactants are favored at equilibrium. Okay? And obviously, since my reactants are on the left side, it's going to favor the left side. And did I have an intermediate or a catalyst? I sure did. I had an intermediate, H+. But you know they're going to say that word explain. So H+ was produced in the first step and then consumed in the second step. Okay, that's it. All right. So let's do an example where you have these two elementary reactions and I want this mechanism. Okay, so I'm going to keep track. That's the mechanism I want. Okay, so I have this equation and I'm looking to see if I need a flip. Okay, so let me go back right over here. Number 1, do I need a flip in the equation? So I'm going to look in just a second. Okay, and then number 2, do I need to adjust coefficients? Okay, so number 1, do I need to flip anybody? Well, I'm keeping track. My HI is on the product, so it doesn't look like I want to flip the first one. My second equation, I do have ammonia on the reactant, but he's over here on the product side. So it looks like I'm going to flip this guy. So I'm just telling AP. And then right here, don't rewrite it. Show AP 1 over that value. So you're going to take this equation. I just put a line through it because I don't want to focus on it. And I'm going to rewrite it, but flipped. Okay? Don't worry about the states of matters. Only worry about the states of matters in that final equation. This is just showing your work. Okay? So my Kp value, I'm going to put 1 over 1.04 to the -4. If you don't want to rewrite it, then just put the answer instead. Okay? So I'm going to plug it in. 1 over 1.04. Let's see, e to the -4. It's going to be a big number. And 3 sig figs, so 9 6. Now it does say 15. You can round. Okay, so 9 6 20. So I'm keeping track. I have my 2 NH3 that I want. Okay, and I do have my N2 that I want. Now, it looks like H2 is going to have to go away sometime. So let's look at this first equation. Iodine right here has a 3, but this equation only has a 1. So it looks like this first equation is going to get multiplied by 3. So I'm going to say 3H2 plus 3 iodines. And because this coefficient's already there, 3 times 2, so I'm going to get 6. And that Kp, I have to not multiply by 3. I got to raise it to the 3rd power. Okay. So on your calculator, you do have a function. On my graphing calculator, you'll have to figure out where yours is. 54. On graphing calculators, you have this little sign. It's called a caret. So you hit that button and then you put a 3. Some of you with scientific calculators, you may have something that says like this, y to the x, okay? So I'm assuming I don't have a scientific calculator in front of me. 54, hit that button, and then 3. So let's see if we all get the same thing. So 54 cube, big number, 3 sig figs, my KP 157000. Okay. AP is more concerned about sig figs than rounding. Okay. So let's see what we have. I have my 2 ammonias. I have my 1 nitrogen. I have my 3 iodines. And I have my 6 HIs. Okay. So 3H2, and I have 3H2 on the product side. Well, that looks like a catalyst right there. So coming together, then I get that mechanism right there. So for my KP overall, I'm going to say KP1 times KP2. So that 157,000 times 9620, big number, 3 sig figs, 1.51 times 10. Let's go scientific on this. Looks like to the 9th. All right, I had to count all that. All right, there you go. All right, so let's see, and I don't think I put the questions there, okay? But I'll put them on there. So part A, we're going to do the same thing that we did above. Does the reaction favor the products or the reactants? Okay. Part B, you answer that question. Part B, does it lie to the left or the right? And part C, was there an intermediate or catalyst? Okay. You answer those 3, finish it up, and I'll see you on the next one.